Python is a high-level programming language based on code readability and simplicity. It is very popular due to its user-friendly nature. Python's main power exists within its packages, which are files that contain code that a developer can incorporate into their project. These packages contain modules which contain the actual code that a developer would want to use in their code to streamline the development process. All of these packages are contained within the Python Package Index, a repository for the Python community. The Python Package Index contains nearly 70,000 Python packages, along with their descriptions, documentation, and downloads. It offers a search function, where if we search, for example, the term Flask, it will attempt to return the most relevant results. However, these results are not well distinguished. As you can see here, many results are assigned the same weight, 9, due to the fact that the metrics used are very limited. Once these results are assigned a weight, they are simply sorted based on alphabetical order, meaning that the actual Flask package will be 4th in the list. This means a developer would have to manually look through a list of results to find the most relevant package. In order to resolve this issue and to streamline the process, PyQuery was created. PyQuery, as shown here, is a search engine dedicated to Python packages and modules. It offers a search engine for both Python packages and one for Python modules. If we search the term Flask, for example, as we did with PyPy, PyQuery will process the request and find the most relevant results to the term Flask. In this case, it returns the most relevant packages in the form of these boxes. These boxes contain information such as the title, the author, a short description, number of downloads, and a score. If we click on one of these boxes, a modal opens up with information pertaining to the package as taken from the PyPy website. If we click over here on the author's name, other packages by the developer will be displayed in case we want to see relevant work. If we click here on Stats, we will see the relevant statistics such as the number of downloads in the last day, week, and month, and certain attributes such as the number of lines of code, number of blank lines, comment lines, warnings, and the number of total files. If we click here, we can visit the direct PyPy page for the package and then proceed to look at the relevant documentation and downloads. Over here, in this circle right here, we have the score for the package as defined by our ranking algorithm. The ranking algorithm takes in metrics, including relevance, which is calculated using the search and analytics engine Elasticsearch, relevance, which is calculated by the Bing search engine's API, and other metrics that a developer might find valuable, such as the number of downloads, number of warnings, and number of comments. PyQuery also offers a module-level search function. If we click here on Modules, PyQuery will return the most relevant modules to our search function. It returns these modules in the form of these boxes, which contain the file path for the module, sample lines of code, and a highlighted line. This highlighted line indicates where exactly in the module a hit occurs, which indicates that this package is the most relevant package to the search query. As we can see here, all of these results are in the same form, and once we decide which one is the one we may be looking for, we can click on it, and it'll return the entire module as a modal. This way, we can first identify which module might be the most relevant to our search query, and proceed to look at the entire module and determine that this is what we want. PyQuery is not necessarily limited to search queries that are the exact name of packages. For example, if we wanted to search something more semantic, such as Web Development Framework, PyQuery will proceed to return the most relevant packages to this search query. This shows that PyQuery is able to take in a semantic search query such as Web Development Framework and still identify the most relevant packages. In this case, Django and Pyramid, which are indeed Web Development Framework packages that are extremely popular and usable. This means that PyQuery is able to be used by both developers who know exactly what package they want or are simply looking for a package that relates to the field they are studying in. Using these techniques, we hope to offer a search engine that streamlines the development process and gives developers a way to easily access Python packages and modules.